Good morning, classes. Hopefully the quiz went well yesterday, and then we're gonna go ahead and finish up the last couple topics for derivatives. You guys are gonna learn what the first derivative test is this week, and then next week you're going to learn the second derivative test. Okay, in order to start that, we need to figure out what extrema are. So if you look on your notes, the extrema are absolute max and mins, and then also relative max and mins. So the definitions of that basically means the absolute maximum is the highest point on the entire graph. Okay. Now it's possible for your graph not to have an absolute maximum. So if both of your arrows are pointing up, that means your graph's going to positive infinity on both sides. So there's never an absolute maximum highest point because it's going to positive infinity. So if we look at the graph to the right, let's go ahead and draw an endpoints at the end. Okay. Then you look at the 5 points, and the absolute maximum, so the highest point on the graph, would be D. Okay. Then the absolute minimum is the lowest point on the graph, okay. And once again, it's possible that there's not an absolute minimum. But on our example to the right, the lowest possible minimum would be point B. Okay. The relative minimum is, the relative maximum is the highest point in a particular region. So it's basically just looking at sections of the graph. One way that I think it's much nicer to remember this is think of the relative maximums as mountaintops and think of the relative minimums as valleys. So anywhere where you have a mountaintop, so notice this would be a mountaintop, mountaintop, mountaintop. Those are going to be relative maximums. So they're the maximum point within a particular region. So in this example, we would have A, C, and D. And then the relative is the lowest point in a particular region. Okay. And I like to think of these as the valleys. So we have 2 valleys. Actually, we have 3, but that one's not labeled with a point. So we're just going to use B and E. Okay. So once again, just in case you didn't see what I just highlighted, there is a valley right here, which would also be a relative minimum, but it's not labeled with a point. Okay, so we're just going to use the ones that are labeled with a letter. So biggest thing here, relative max are the mountains, relative mins are the valleys, and then absolute max is the highest point of the entire graph, which means there might not be one. And then the absolute minimum is the lowest point on the entire graph. There might not be one. Okay. All right, so the first derivative test is going to allow us to figure out when a graph is increasing or decreasing without actually looking at the graph. So in order to do that, we should understand first what increasing means. So f of x, or in other words, the y values, get larger as the x values get larger. Okay. And then decreasing is, once again, it's f of x, which is the y values, get smaller as the x values get larger. So notice that we always read our graph left to right. So the x values will always be getting larger. If the y values are also getting larger, then your graph is increasing. If the y values are getting smaller, then your graph is decreasing. Okay, so we are going to go ahead and take a look at the Extrema, okay? And we need to make sure that we write our increasing and decreasing in terms of interval notation. So if we forgot what interval notation is, let's say if you have -5 to 2, that basically means -5 is less than or equal to x, which is less than 2. Okay, so open bracket means we don't include the point, closed bracket means we do. All right, so just like you're going to do on your homework, what is the absolute maximum on this graph to the right? Okay, hopefully you're thinking none. The reason being is notice that this graph is going to positive infinity on the right, which means I continually just get bigger and bigger and bigger and bigger. Therefore, I do not have an absolute highest point from the entire graph. The absolute min. That's going to be the same thing. There isn't going to be one due to the fact that this graph is pointing down, meaning this is going to negative infinity, so I'm never going to have a lowest point. All right, relative maxes. So remember that's all of the mountaintops. So we have one there and one there. And we're going to write these as ordered pairs. Okay. And then we're going to do the relative mins. These are the valleys on the graph. So -1, 3, and 4, -1. Okay. Then we need to decide where the graph is increasing and decreasing. Now, when you guys are writing these intervals, make sure that you write them in terms of x. So we always write interval notation in terms of x, not the y values. Okay? And you need to make sure that you cover the entire number line if your graph is going to infinity and negative infinity. Okay, remember that negative infinity can never be on the right, positive infinity can never be on the left. You read it like a number line. So let's first identify where the graph is increasing. So increasing up to this point, then we have another section here, and then the third piece there. So in interval notation, we're coming from negative infinity to -3, and these are going to be open brackets because at the max and the mins, we are neither increasing nor decreasing. So the union symbol, and then from -1 to 2, and then 4 to positive infinity. So notice that I used all of the x values to write my interval notation, okay, and I used open brackets for all of it. So now let's go through and do decreasing. It's just going to be the other pieces, and notice now we cover the entire graph, which means we need to cover the entire number line. So -3 to -1, union symbol, 2 to 4. Okay, when you write your interval notation, it should be in numerical order. And then check to make sure you cover everything. So I go from -3 to -3, -3 to -1, -1 to 2, 2 to 4, 4 to infinity. So I can read this from left to right, and I make sure that all numbers are covered. All right, let's go to the next page of the notes. Okay, so we're going to begin talking about the first derivative test and what it allows us to figure out. So first of all, if when we go to find the derivative, it's positive, then that means f of x is increasing. Okay, so if the derivative is positive, then we are increasing of the original function. So that means that the original function would be going this way, it'd be getting bigger, okay? If f prime of x is negative, then that means the original function is decreasing, okay? The critical numbers is where the derivative equals 0. So that means your graph is neither increasing nor decreasing. So for example, if this was my graph, down here at the bottom, at the minimum, that would be where the derivative is 0 because we are neither increasing nor decreasing from the original function. Okay? All right. If f prime of x changes from negative to positive, okay, that means that the original function is changing from decreasing to increasing. Okay? So if f prime of x goes from negative to positive, then that means the original graph is going from decreasing to increasing, therefore creating a valley, so that's a relative min. Okay, and that's so important to know. So the valleys create a relative minimum. If f prime of x changes from positive to negative, then that means our original function is going from increasing to decreasing, creating a mountaintop, which is a relative maximum. Okay, so minimums create valleys, maximums create mountaintops. Okay, so if you haven't already done so, I would highlight this section. This is essentially what the first derivative test allows us to figure out without looking at a graph. All right, so let's take a look one more time at a graph, okay? And I'm gonna go ahead and add in arrows at the end of this. So a critical number, remember, is where the derivative is 0. So remember that the derivative is the slope of the tangent line. So if I basically have a horizontal line, then that means that the derivative is going to be 0, okay? Also, they occur at the max and the min. So the critical numbers are going to be at 1 and 2. As a side note, if I asked for the critical points, then you would write them as an ordered pair. So you would say 1, 2, and 2, 1. Okay? So critical number means just write the x value. Critical point means write the ordered pairs. All right, so where is our graph increasing? Oops, sorry, I meant to use the highlighter there. There we go. So we're increasing from here to here, and then there's the other section. So increasing from negative infinity to 1, and then again from 2 to infinity. Notice that our intervals start at those critical points. And then we just have one section of decreasing, which is from 1 to 2. Okay? Once again, make sure that your number line is covered, so negative infinity to 1, 1 to 2, 2 to infinity. Okay? Relative maximum points occur at the mountaintops, so 1, 2. Notice that the graph is changing from increasing to decreasing, and if we go back up to this little section here, if we change from increasing to decreasing, then we have a relative max. Okay. The relative min point is going to be at 2, 1. There we have a valley, and we're going from decreasing to increasing. Okay, so let's just take a look at terminology here. Point means an ordered pair. So if it says point, it's an ordered pair. Okay. If it says y value, or just the value, then that means that they are asking for the y value of the ordered pair. So if we look at our example, the relative maximum value is going to be the y value of the relative maximum point. So 2. And then the relative min value is going to be the relative y value of the relative minimum point. Okay? I can't tell you how many times we get that terminology mixed up. So if it says point, it's going to be an ordered pair. If it says value, we just want the y value of the points. Okay? Y value, y value, y value. Not the x value, just the y value. Okay? When we go to do little check-ins in the next couple days, when it asks you for the value, it's the y value. All right. So let's get into actually doing the first derivative test. Okay, so to start the first derivative test, we actually need to take the derivative. So that's going to be their first step in all of these problems. So take the derivative, so f prime of x, and we're just going to use the power rule here. So we're going to bring down that 2 and make that 6x, and then minus 12, and then the derivative of 5 is just 0 because it's a constant. Okay? So the first thing you want to do is take the derivative because we're using the derivative test. All right? Next thing I want to do is find the critical numbers. Remember that the critical numbers is where the derivative is set equal to 0. So that's going to be our next step, setting the derivative equal to 0. So let's solve for x. We get x to be 2. So that is my critical number. Okay, it didn't ask for the critical point, it asked for the critical number. So we have one critical number. So let's go ahead, we're going to set up this little chart, and this is what you're going to do every time you do the first derivative test. Okay, and then you're going to draw on vertical lines for as many critical numbers that you have. So if you have 3 critical numbers, then there should be 3 vertical lines. If you have 2 critical numbers, there should be 2 vertical lines. Okay, and so forth. So we have 1 critical number, so that means there's 1 vertical line. Okay, and at the top of that vertical line, I'm going to write that x equals 2. Okay, and then this top row is going to be f prime of x. The middle is going to be f of x. And then the bottom is going to be the interval. Okay. Now before we actually even start doing the test, we can fill in the interval. So the interval starts from negative infinity and it stops at the critical points until it gets to infinity. So hopefully we recognize that there's 1 critical number, so that means we're going to stop once. So we're going to start at negative infinity, we're going to stop at 2, and then on the flip side of that vertical line, we're going to start back up at 2 and go to positive infinity. So those are our intervals. Okay, next thing. The first derivative test means we actually need to test numbers in the derivative, hence the first derivative test. So you just need to pick a number to the left of 2. Okay, and essentially it's any number from negative infinity to 2 because that's the interval that we're working with. So I'm just going to go ahead and use 1. So I'm going to do f prime of 1. Okay, once again, we are testing the derivative test, the first derivative test, so we test in the derivative. Okay, all we really care about is if the number is positive or negative. So I'm just going to do some work down here. So 6 times 1 minus 12 gives me a negative number. So that is negative. Okay, from the previous page of the notes, if the derivative is negative, then that means that our original function is decreasing. Okay, so we're going to draw on a little arrow to show that it's decreasing. Okay, now I need to test another number. Okay, I need to test now to the right of 2. So f, I was going to use a different color. So f prime of 3, and it just needs to be any number to the right. So some work down here. Once again, all I care about is if it's positive or negative. I don't care about the number itself. And it's positive, So that means our graph is increasing on the interval of 2 to infinity. Okay, so if f prime is positive, that means f of x is increasing. If f prime is negative, then that means that f of x is decreasing. Okay, then I think it helps to take a highlighter or your pen and trace what this graph looks like, okay, with the arrows. So your graph is going to follow the arrows. And you're going to have a critical point down at the bottom in this example, okay? So just looking at this, hopefully you recognize that this is going to be a relative min, okay? Two ways we know this. One, it's a valley. Two, f of x changed from decreasing to increasing, which creates a relative minimum, okay? So we need to actually find that relative minimum point. Now here's the tricky part. The relative minimums and the maximums are from the original graph. So the original f of x. So when we go to find the minimum or the maximum, we have to plug x back into the original function. So I'm going to do f of 2. Okay, this is why notation is important. So 3 times 2 squared minus 12 times 2 plus 5. Okay, and that gets me a -7. So the relative min is 2, -7. Okay, if you're wondering why I plugged in 2, that's what the critical point was. All right, we now have all of our information from the first derivative test and we can plug everything in. So our graph was increasing from 2 to infinity. It was decreasing from -infinity to 2. Notice that I covered the entire number line. We didn't have a relative maximum point, which means we're not going to have a relative maximum value. We didn't have any mountaintops. And then we have a relative minimum point at 2, -7. So remember that point is an ordered pair. And then the value is just the y value of that relative minimum point. So -7. So that is the first derivative test. Okay, I know it's a lot. We're going to do another example together. And then I know this video is really long, sorry, but tomorrow the video is literally just me doing one problem with you guys on the homework, and then you have the rest of the time to work on homework. And then Friday's video is not going to be long either because it's going to be me doing the homework with you guys on a couple problems and then you finishing it up on your own. Okay? Okay. There's definitely people in this class that catch on to material quickly, so please, 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 especially with me not being here, I'd really appreciate if you guys help each other out, okay, and take really good active notes. All right, so first derivative test means we actually need to take the derivative. So f prime of x, we're going to apply the power rule, so 3x squared. And then when you bring down that 2, they're going to cancel out and you're left with minus 3x. Okay. To find the critical numbers, you're going to set the derivative equal to 0 because that's where the critical numbers occur. That means that your function is neither increasing nor decreasing. Okay, and a lot of times we just make algebra mistakes on the critical numbers. Unfortunately, if you make a mistake on the critical numbers, then the entire problem is going to be wrong. So just make sure that you're doing your algebra here correctly. Okay. Anything with a variable has to be set equal to 0. So we get x to be 0 and 1. Okay. So those are our two critical numbers. X equals 0 and 1. Now, when we go to set up the first derivative chart, put your critical numbers in numerical order. That's a big active note. Okay, so your critical numbers need to be in numerical order. And since I have two critical numbers, I'm going to have two vertical lines. So x equals 0, x equals 1. So f prime of x is the first row, then f of x is the second row, and then we have the interval. Okay, and we can fill the interval in right away. It's -infinity to 0, 0 to 1, 1 to infinity. So remember that the interval starts at negative infinity and goes to positive infinity, and you just break at the critical points. This is why it's important that the critical numbers are in numerical order. Okay? All right, so we need to test a number, okay? And we're going to test a number to the left of 0 that's in that interval of negative infinity to 0. So f prime of 0. Since I'm using the first derivative test, I'm going to plug it into the first derivative. Okay? Sorry, I didn't mean to choose 0. I was saying 0 and then, there we go. All right, so it needs to be to the left of 0, so let's try negative 1. Okay, so 3 times negative 1 squared minus 3 times negative 1. All I care about if this is positive or negative. This is positive, so that means our graph is increasing. Okay. All right, let's test a number in between 0 and 1, so I'm just going to test 1/2. Okay, so 3 times 1/2 squared minus 3 times 1/2. So plug that into your calculators or your brain. Doesn't matter what the number actually is. All we care about is if it's positive or negative. Okay, this is going to be negative, so that means my graph is decreasing. Okay, and then finally, pick a number to the right of 1. So I'm just going to pick 2. Plug it into the first derivative. Okay, and notation is important because we're going to eventually get to a second derivative test. So this is positive, and it goes to infinity. So that means it's increasing. All right, so trace this. I think it helps to see what the graph looks like. And then mark your points. So that's going to be a mountaintop, so that means we have a max. That's going to be a valley, so that means we have a min. Okay, so we need to find the actual ordered pairs at the max and the mins. So I need to take 0 and plug it back into the original function because that is where the maximum occurs, is on the original f of x. So I get 0 minus 3/2 times 0 squared, and that just gives me 0. So the relative maximum is going to occur at 0, 0. Okay, then I need to take the relative minimum number and plug it into f of x. So I get 1 cubed minus 3/2 times 1 squared. So that gives me 1 minus 3/2, which is negative 1/2. So the relative minimum point occurs at 1, negative 1/2. Okay. And now we have all our information. So we're increasing at 2 spots here, right? They were the red arrows that I originally had drawn in. So that's going to be from negative infinity to 0, and then 1 to infinity. Then we're decreasing for where f prime of x is negative, so that's going to be 0 to 1. Like I keep saying, make sure this covers the full number line and make sure it's in numerical order. We have a relative maximum point at the mountaintop, where our f prime of x changed from positive to negative. So that's going to be at 0, 0, which means the relative maximum value is at 0. And then the relative minimum point occurred at 1, negative 1/2. And then the relative minimum value occurred at negative 1/2. Okay? I tend to find these problems a lot of fun. I know some of you probably just rolled your eyes at me, but it's the same thing over and over and over and over again. Okay? It's very systematic once you understand the system, and as long as you do your algebra correctly, then the problem should work. Okay? Your homework kind of has some length to it tonight, so that's why I said tomorrow. I think the video is only like 10 minutes long. It's one problem to do with you guys. And tomorrow's homework only has 3 problems, so plenty of time between tonight and tomorrow to get both worksheets done. One thing is, on tonight's worksheet for 3.6a for number 6, make sure that you fill in the gaps, okay? And if you don't know what I mean by that, check the answer key, okay? And the gaps are filled in for you, okay? All right, thanks for listening. Sorry this was such a long video, but I do appreciate the time and your attention. Hope you have a wonderful day, and I will talk to you tomorrow. Bye.